All right, guys, today we're going to talk about factors and multiples. So how we're going to run these YouTube videos is I have everything typed up that you're going to need to write down. I make these ahead of time so that I can quickly make them since I do it on my own free time and it's not something I'm required to do. So because of that, you'll notice, as you can see on this first slide here, where my mouse is, there we are, I already have some definition words typed up. So what I'm going to do is I'll talk about them and I'll say, hey, go ahead and pause the video. That's your cue to pause that video and write down whatever it is that I have typed. Typically, if you see things typed, it's something that I would then type on the board that we would do together. And you're usually watching these videos for one of two reasons. One, you need a little bit more help or you weren't really paying attention. So you're like, hey, I should probably figure out what we talked about in class today. Or two, you're that person who is absent, and so you need to watch this video in order to get caught up. So this will have all the generic information that we did in class. You just won't have that peer-to-peer interaction, and you won't have that any of the topics or conversations that we had in class. You won't be able to experience any of that. Okay, let's go ahead and get started. So factors and multiples. What is a factor? A factor is two numbers that multiply into another number. For example, they're smaller than the original number. So think about it this way. What multiplies to 6? 2 and 3 are factors of 6. Next definition is a multiple. A multiple are lots of numbers that multiply into bigger numbers. They are bigger than the original number. So for example, the multiple of 2 is 2, 4, 6, 8, 10, 12, so on and so forth. So factors, two numbers that make one number, multiple, lots of numbers that keep growing and getting bigger. Now would be a good time to pause. All right, first example, what are the factors of 20? Well, we could write this one of two ways. We could have 1 and 20. We could have 2 and 10. That's a bad 0. Let me try that again. And we could have 4 and 5. Or some other people like to do 1 and 20, 2 and 10, and 4 and 5. Either way you write it, doesn't bother me. What are the multiples of 20? Again, multiples grow bigger, so 20, 40, 60, 80, 100, so on and so forth. So factors, two numbers together, multiples, lots of numbers. Greatest common factor, also commonly referred to as a GCF. Now you see this nice little handy dandy note bubble down here that says math people are lazy and we like to shorten stuff as much as possible. So you will constantly see that phrase shortened as GCF. Oh, that is not what I hit at all. Go back. So what is the GCF? It's the largest factors between two or more numbers. All right, so let's take a look at this example. There are 1 slice servings of 3 different types of cake on a table. Each row has an equal number of servings and only one type of cake. What's the greatest number of servings in each row? Excuse me. So here I have a table, and I see I have 3 different types, so I'm going to assume I have 3 different tables. I'm going to say this row is my marble, this is my red velvet, and this is my chocolate. I just picked some random number. 3 is what I did. In this row of marble, in this top row, I have some specific number of pieces. And whatever that number is, it's the same. I also have the same number of red velvet. and I have the same number of chocolate. So we're trying to figure out what that red number is for every single row. It tells me that I have 10 pieces of marble, 15 of red velvet, and 20 of chocolate. So I want to know what number could all of those I want to know what number those three numbers could have in common. So we're going to go ahead and we're going to use the GCF to determine that, the greatest common factor. So what are my factors of 10? I've got 1 and 10, 2 and 5, and that's it. What about my red velvet? That's the number 15. I've got 1 and 15, 3 and 5. And that's it. And then lastly, my chocolate, which is 20. I have 1 and 20, 2 and 10, 4 and 5. So the idea here is to determine what number what factor does each of the three numbers in front have in common? I've got a 1 and a 10, 2, 5, 1, 15, 3, 5, 1, 20, 2, 10, and 4 and 5. So if you notice, each number has a factor of 5. So because each number has a factor of 5, my rows in common can have at most 5 pieces of cake. Because again, we have to have the same amount of cake on each row. So the cat likes to knock things off my desk. He's trying to be cute. All right, let's take a look at another example. Lana earned $49 on Friday, $42 on Saturday, $21 on Sunday, and she did this by selling bracelets. She sold each bracelet for the same amount. What's the most she could have charged? Again, we got to figure out what factor the following numbers have in common. So 49, you got 1 and 49. 2, no, 3, no, 4, no, 5, no, 6, no, 7. 7 goes in. So those are the only factors of 49. Oh, 42's kind of got a lot. We have 1 and 42, 2 and 21, 3 and 14, 4, no, 5, no, 6, and 7. 21 is 1 and 21, 3 and 7, 4, 5, 6. Nope. So we want to take a look and ask yourselves, what number is there in each number? What factors in each number? I've got a 7, I've got a 7, and I've got a 7. So the most she could have charged is $7. Warren has 60 carrot sticks and 42 celery sticks. He wants to package them in plastic bags so that each bag has an equal number of carrot sticks and celery sticks. What's the greatest number of bags he can put together? Again, GCF, greatest common factor. What I would like you to do on this one is I would like you to pause the video yourself, determine the GCF of the two numbers provided, and then compare your answer to mine. So go ahead and pause that video. All right, you should have come up with the GCF of 60 and 42 being 6. So in this case, he can put 6 bags together of his carrot and celery sticks. Next thing we're going to talk about is a factor tree. What is it? A factor tree is a picture version of factors using prime numbers. And you're probably like, oh, what on earth is a prime number? A prime number is a number that is bigger than 1 and whose factors are 1 and that number. So we're going to use a factor tree to determine the GCF of 12 and 18. So I'm going to write my 12 and I'm going to write my 18, and I'm going to kind of give them some space. So what's two numbers that multiply to 12? Any two, besides 12 and 1, because that's not really going to help me, because I'm still just going to have to break down 12. So what's the number that goes into 12? Well, we could do 3 and 4. If you pick 2 and 6, do you think that's wrong? Nope, it's just different. Now I want to see if I can break down these numbers. Well, 3 breaks down into 1 and 3. Those are the only two numbers that multiply together. So 3 is what we call that prime number. Since he can't break down into anything with a factor larger than 1, we're going to leave him alone. However, 4 can break down. 4 can break down into 2 and 2. Don't circle these. I'm just pointing out that my prime factors of 12 are 2, 2, and 3. Now let's try 18. 3 and 6 sounds great. Again, 3 can't be broken down, but 6 can. 6 can be broken down into 2 and 3. Again, we see that my factors are 3, 2, and 3. Now I want to find the greatest common factor. So I want to look for any numbers they have in common. So for example, I see they both have a 3 and they both have at least one 2. So my factor is not 3 or 2, my factor is 3 times 2. Since we've used multiplication and division to break these numbers apart, my final answer will be both of the numbers put back together, which in this case is 6. So the greatest common factor of 12 and 18 is 6. All right, greatest common factor of 12 and 66 using trees. Well, we just did 12. Let's try it a different way, just so you get used to saying, hey, there's not one exact way to do it. Some people try and go after different ways, so I'm going to try something different as well. So 2 and 6, which gives me 2 and 3. And again, I'm not circling. This isn't my final answer. I'm identifying my factors, my prime factors, so that I don't forget. And then 66. Well, let's see. 2 and 33. Now, 2 we already have discussed as prime. We've seen that a few times, but 33. It seems like it might be prime, but it's actually not. 33 can break down into 11 and 3. And again, those two numbers are prime themselves. So what would be my greatest common factor here? Well, they both have a 2, and they both have a 3. So the same idea. In this case, it's the exact same greatest common factor. It's 6. All right, I want you to try this one on your own. So pause the video, see what you get, come back and see the answer. And of course, the answer is 6 again. Next definition, LCM, least common multiple. Remember, we are lazy in the math department. We shorten things as much as we can. The LCM is the smallest number that is a multiple of 2 or more numbers. So something that they both go to that's the smallest possible. Okay. I don't know why I have that extra color there. You don't really need it. I think I was having a silly moment when I wrote the notes. So we're going to find the least common multiple of 2 and 3. Oof. So one way to do it is not very straight, so I apologize. Is to grab to write out, a number line. For 2, so every time I see a 2, I'm going to put a red X. And by a 2, I mean a factor of 2, multiple of 2. It's been a long day, guys. Every time I see a multiple of 2, I'm going to put a red X over it. So 2, 4, 6, 8, 10, 12, 14. We can keep going on and 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 on. Every time I see a multiple of 3, I'm going to put a purple X. So 3, 6, 9, 12, 15. Now, what's the earliest these two meet? And I don't mean sitting next to each other because we think they'd meet there, but they don't. They meet when they're sitting on top of each other. Well, I see that 2's only got a red, 3's got a purple, 4's got a red, but 6 has a red and a purple. I see again a red and a purple over 12. I want my smallest. That's the whole part of that L, that least common. So the least common multiple of 2 and 3 is 6. What's another way of looking at the exact same problem? Well, I could have just taken, what colors did I do? I did red and purple. I could have just listed the multiples, 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth. And then 3, 6, 9, 12, 15, 18, 21, so on and so forth. And I could have identified, okay, what number do they have in common? They both have a 6. You always have to draw a number line? Nope. Is that one way to do it? Yep. Will I be upset if you do it that way? Nope. It's just the way you like to see it. All right, what happens when my least common multiple is a little bit bigger? Like 14 and 21. So what I like to do is, instead of trying to remember 14 and then what, 28 and then, keep going. No, thank you. Is we can take the two numbers. We can use a factor tree to find their prime factorization. So for example, 14 is 7 and 2. 21 is 7 and 3. And then we identify one of each number. So the reason I didn't underline the second 7 is I already underlined the 7. And then what I can do is I can take that 7, and I can multiply it with that 2, and I can multiply it with 3. 7 times 2 gives me 14. And 14 times 3, let's see. 12. 3 times 1 is 3 plus 1 is 4. So the LCM of 14 and 21 is 42. Okay, so these are my last 3 examples. Your job is to pause the video, answer the question of finding the following, whichever you prefer, and then check your answer. I'll give you a hint on this one. If it can go into 5, I'm sorry, let me go backwards. I just said that backwards. If it can go into 10, then it can go into 5. That's my little hint. All right, pause that video. All right, I hope you got those answers. Have a good one, guys.